Hello. Here we're going to discuss optimization problems. So first, let's look at the optimization first derivative test. So the first derivative test for optimization problems is that again we are given a function of x, and we find its first derivative. We set the first derivative equals 0, and then we solve for x. We get two critical points, for example. Here we're using c and the d as two critical points. And then we plot them on the number line. And on the first row, we put f prime of x. The bottom row, it's f of x. So we study the signs of the first derivative. When the first derivative is positive on the interval a to c, we say that the function is increasing on that interval. Where the first derivative is negative, like here between a c and d, we say that the function is decreasing. Again, because the function is increasing on AC and they started decreasing on CD, so that will make x equals c as the absolute maximum. So we will say f of c is the absolute maximum value of the function, which is a little bit different than what we studied in section 3. In section 2, we're only looking at local maximum, local minimum. Here, those maximum value are absolute maximum. Again, here, since the function is decreasing from c to d, and it start increasing at d to b, then we said at x equals d, there's an absolute minimum value, which is going to be f of d. So this is the first derivative test for the optimization problem. So let's do an example. The first example says, find the two numbers whose difference is 100 and whose product is a minimum. So when you read the problem, you have to do the analysis. You know they're asking you for two numbers, and the difference of the two numbers must be 100. So when we think about the difference of two numbers, then one number must be bigger than another because the difference is positive. So you say you use x and y as two numbers, and then the difference is that you take x minus y, it gives you 100. Okay, so that's the first part from the beginning up to here. Then when you continue, it says and whose product. So when you multiply those two numbers, the product is going to be a minimum. So because of this minimum, it tells you we're doing the minimization problem. Okay. So it says when you take the product of two numbers, so x times y must give us some function, f, and then we're going to find the minimum of that function f. So you write f equals x times y. But the intention here will be to express the function f as a function of one variable. So we're going to try to minimize the function f. So we know x minus y equals 100. We already have this relation here between x and y. So we can solve this equation for x. So you get x equals y plus, by adding y to both sides, you get x equals y plus 100. Call that equation 3. And then we're going to go back to this function f equals x times y, and then replace x by y plus 100. So we're going to substitute y plus 100 for x, so that this function will then become just a function of one variable, which is y variable. And then from here you distribute y, you get y squared plus 100 y. So this is the function that you're going to minimize. Okay. Minimized because on a problem it says the product is a minimum. So it tells us we're dealing with a minimization problem. So minimum implies that we needed to take the derivative of the function because we're looking for minimum value. So we take the derivative, we get a 2y plus 100. We set the derivative equals 0 so we can find the critical point. So 2y plus 100 is 0. You get y equals negative 100 over 20. Negative 100 over 2, which gives us negative 50. So y is negative 50. That's our critical point. And then that's the one of the number. Okay. So we go to the relation x minus y equals 100 to get the second number, which was x. So we plug in negative 50 for y to get y to be 50. So the two numbers that we're looking for are 50 and a negative 50. We can do another example. For this example, they ask us to find the two positive numbers whose product is 100 and whose sum is a minimum. Again, another minimization problem. So find the two positive numbers. So here we're looking for two numbers who are positive. And whose product, so if you multiply the two numbers, it's going to give you 100. And if the sum is a minimum, if you added these two numbers, you're going to get a minimum, the smallest number possible. So let's do the analysis. So we're going to call x and y the positive two numbers that we're looking for. So that's why we write x is greater than 0, y is greater than 0. Product means multiplication. So if you take x times y, you get 100. Sum means addition. So if you take x plus y, it gives you f, the function that we're going to try to minimize. Okay, but we need to change this function to become a function of single variable. We're going to use this relation, x times y equals 100. So we're going to solve for x, for example. We get x equals 100 over y, and then we plug in 100 over y for x into into f. Okay, so replace x by 100 over y, you get a function of y. So this is the function we'll need to minimize. Minimization implies first derivative. So we take the first derivative. So we're going to take the derivative of this equation, this function. Okay, so the derivative of 100 over y is negative 100 over y squared. I explained it over here. And then derivative of y is 1. So to find the critical point, we have to set f prime of y equals 0 and then solve for y. So when we set 100 over y squared plus 1 equals 0, we can move, we add 100 over y squared to both sides, and then we multiply this equation by y squared, and then we have y squared equals 100. We take the square root to both sides, so we get plus and minus 100, but we're looking only for y to be positive. So we're going to get rid of negative 10, we keep 10. So the number that we're looking for is, one of the number is y is 10. So then we know the connection, x equals 100 over y, and then to get x, we take 100 divided by 10, and then we get x equals 10. So the two numbers that we're looking for is 10 and 10. Thank you.